Number 1 says solve this system, and it gives us two different equations. So you have a couple different ways that you can solve systems. This one is set up nicely for elimination. And when you're doing elimination, you're either deciding to add the two equations together or to subtract them. And what you want to look for is the numbers in front of each variable. So in this case, we're looking at the 5 and 10 to see if they're the same number or if they're opposites, which they aren't. So then if we look here at the number in front of the y, it's a 4 and a -4. So since those two numbers are opposite numbers of each other, we're going to add these two equations together because those will add to 0. So we'll take 5x plus 10x, which is 15x. Then 4y plus -4y is 0. So I'm just going to write the plus 0 here. You don't have to, but I want you to see that it cancels out. And then 8 plus 46, which is 54. So then you have really just 15x because 15x plus 0 is just 15x. So we have 15x equals 54. So then you will divide both sides by 15 so that you get down to just 1x, because 15x divided by 15 is just 1x. 54 divided by 15 is 3.6. So then you find out that x equals 3.6. Once you have the x variable, or one of your variables, solved for, then you go back in and plug it into an equation. Doesn't matter which equation. I'm going to plug it back into the top equation. And so I'm just going to leave a little blank here where the x is. So this is my 5x plus 4y equals 8 equation. And instead of typing x, or instead of writing an x, I'm going to write 3.6, since we know that's what x equals. Then you're just going to go ahead and simplify this. So 5 times 3.6 gives us 18. So we get 18 plus 4y equals 8. 18 and 8 are like terms, but they're on different sides of the equation. So we're going to need to subtract 18 from both sides, because 18 minus 18 is 0 plus 4y. And then 8 minus 18 is -10. And we know that 0 plus 4y is just 4y. So then we'll divide both sides by 4 so that we get down to 4y divided by 4 is just 1y. And then -10 divided by 4 is -2.5. So we get that y is equal to -2.5. Then you'll want to write your answer as an ordered pair. And remember, ordered pairs are x first, 3.6, and then the y second, -2.5, and then that's your solution to this system. Number 2, select all equations that share a solution with this system of equations. So really that's asking you to find what of these equations is equivalent to these ones. So the ways that you've been looking at these is you're either adding the two equations together or you're subtracting them, is two of the big ideas that you've done here. Now, adding is commutative, so whether you take the top one plus the bottom one, or you switch it around and do bottom plus top, it's not going to matter. It's going to give you the same answer. So let's go ahead and over here, let's add the two equations together so that we can see what we get when we add them together. So we're going to go ahead and plus these. So 5x plus 2x is 7x. 4y plus -7y is -3y. 24 plus 26 is 50. So that's what we get when we add the two equations together. So if we take a look here, A has a +3, that's not +3y, that's not what we got. B has this positive 7x, the negative 3y, and the 50. So that's when we add both equations together. Now we can subtract the equations. And when we subtract the equations, the order matters. So I'm going to write them back down this way. And when we subtract them this way, we're going to get an answer. So when we subtract, and I like to put parentheses here because we're subtracting this whole equation. So we're doing 5x minus 2x. Well, 5 minus 2 is 3. So 5x minus 2x is 3x. 4 minus a negative 7. So I'm just going to write that off to the side so you can see what's happening. But 4 minus negative 7 is really plus. Minus a minus turns to a plus. So we get 11y here. And then 24 minus 26 is negative 2. So when we subtract the equations that way, we end up with letter E. I'm going to get some of this out of the way here. I'm going to just make these a little bit smaller so I get some more room. So now when we change the order of the subtraction, okay, so when I subtract the first one from the second one, so when I write it like this, that's going to change the answer. So we can subtract these this way. So now we're doing 2 minus 5. So 2x minus 5x is negative 3x. Negative 7y minus 4y. So negative 7 minus 4 is negative 11. And then 26 minus 24 is positive 2. So that's another way we could subtract it. Now that one's not on here. Okay, so that's not one of our solutions here, but it is one that would work. And then the final thing, so let's take a look. So we know this one is wrong because it had the positive 3. We know this one is wrong because it had the negative 11. So let's take a look at the one that they did here. So they're saying 5x plus 4y is equal to 2x minus 7y, which is not true because 5x minus 4y is equal to 24 and 2x minus 7y is equal to 26. So those two are not equivalent to each other. So just B and E in this case. Number 3, students performed in a play on a Friday and a Saturday. Both performances, there were adult tickets cost $A and student tickets cost S. On Friday, they sold 125 adult tickets and 65 student tickets, and they collected $1,200. Then on Saturday, they sold 140 tickets, adult tickets, 50 student tickets, and they collected $1,230. So then they give us this equation that represents that situation. So 125 adult tickets plus 65 student tickets gave us $1,200. 140 adult plus 50 students equaled $1,230. So what could this equation mean? 265A plus 115S equals 2430. And if we look, 125 plus 140 gives us 165 adult tickets. 65 student tickets plus 50 student tickets gives us 115 total. And then 1,200 plus 1,230 gives us $2,430. So this is just the total of these two equations, which is just the total tickets and money from Friday and Saturday. So from the weekend. So it's the total amount of tickets and money that they sold and money that they earned. So the solution to the original system is A equals 7 and S equals 5. Explain why it makes sense that this pair of values is also a solution to this equation. And that's because this equation is equivalent to the system. So then a solution to each of these equations or to this original system is going to be a solution to this one since it's an equivalent expression. Number 4, which statement explains why 13x minus 13y equals negative 26 shares a solution with this system? And so how do we know that? And if we look, so how do we go from 10x and negative 3 to 13x? And this is through subtraction, because 10x minus negative 3x gives us 13x. So that gives us that 13x. And then we can look at the rest of it and see. So negative 3y minus 10y gives us negative 13y, which is what happened here. And then 29 minus 55 gives us that negative 26. So we subtracted these equations. So when we're looking at our multiple choice answers, we want to look for subtraction. So because it's the product, no, because product means multiplication. All three equations have the same slope but different y-intercepts. That's not anything we just talked about. Because 10y minus 3 is equal to 29, so I can add to the left and add to the right. Well, that's true, you can. So we can add 10x minus 3 to the left and 29 to the right, but we didn't because we subtracted them from both sides. Okay, so we subtracted this 3x plus 10y from the left, and we subtracted 55 from the right. Number 5, select all equations that can be the result of adding these two equations or subtracting them from each other. So let's go ahead and add them. So x plus 3x is 4x. 1y minus 5y, or sorry, plus negative 5y is negative 4y. And then 12 plus 4 is 16. So 4x minus 4y equals 16 is when we add. So D is wrong with that plus 4y. Then we can also subtract. So let's write down the system here at x plus y equals 12, and then 3x minus 5y equals 4. We also know that subtraction, you can't, you don't get the same answer when you switch. So let's switch the equations so that we can get both of the two answers. All right, so when we subtract 3x minus 5y equals 4 from x plus 12, so 1x minus 3x is negative 2x. 1y minus negative 5. So 1 minus negative 5, remember, turns to plus. So this is plus 6y. 12 minus 4 is 8. So negative 2x plus 6y equals 8 is a solution. And then if we flip it around and we subtract the x plus y equals 12 from the first equation, so 3x minus x is positive 2x. Negative 5y minus y is negative 6y. And 4 minus 12 is negative 8. So we have 2x minus 6y equals negative 8, which is E. So then we did not get A or F when we added or subtracted. So you just get the answers B, C, and E. Number 6 wants us to solve each system of equations. So in part A, we hopefully see in this bottom equation that we only have one variable. So that means we can solve for x right away by just dividing by 7. So then we end up getting x equals 12. Then you can go ahead and plug this into this top equation here. So you can just plug 12 in for x. However, we know if we do 7 times 12, it's going to be 84. It shows us that right here. So you could just start with 7x being 84 minus 12y equals 180. And again, if that's too big of a leap, this is really just 7 times 12. We plugged in 12 for x, and 7 times 12 is 84. So now the 84 and the 180 are like terms, but we need to get the 84 off of this side. So we're going to have to subtract 84 from both sides, because 84 minus 84 is 0. then we have negative 12y, and then 180 minus 84 is 96. So then really 0 minus 12y is just negative 12y. And we can divide by negative 12. And we end up with y equals negative 8. And then you can write this as an ordered pair because we often write our solutions as ordered pairs. So writing your x first and your y second. Then our second system, you can see that this one is solved for x. So it's not solved for x. And the reason I'm looking at the 4x is because I see that there's a 4x here. So I can substitute in the negative 16y in place of that 4x in the bottom equation, because we know that 4x is the same as negative 16y. So then we can go ahead and simplify here. So negative 16y plus 27y is going to give us 11y. So 11y equals 11, divide by 11, and we end up with y equals 1. So I'm just going to put that into my ordered pair right now. So the y value I got was 1. Then we're going to go ahead and plug this in to this top equation. So when we do that, we're going to get negative 16 times 1 equals 4x. And so then we get negative 16 times 1 is negative 16 equals 4x. So then divide by 4, and we get negative 4 equals x. So then that would be our solution, negative 4, 1. Number 7 gives us another system of equations, and it asks us if we would rather use subtraction or addition. Now with subtraction, you want the same coefficients on a variable, and with addition, you want opposites because you want them to equal out to 0. So in this case, our x's are the same number and our y's are opposite numbers. So you can do either of these. It just depends on your personal preference. So either answer is fine here as long as you back it up with y. So for me personally, okay, I would choose addition because for me, addition is easier. And that's because subtracting negatives can sometimes be complicated, right? Or cause issues, right? So when you minus a minus, it turns to a plus. So for me personally, and you can have a different answer, I would just choose addition so I didn't have to deal with the subtracting negatives. Number 8, the box plot represents the distribution of the number of free throws that 20 students made out of 10 attempts. After reviewing the data, the value 1 was determined to have been an error. This box plot represents the distribution of the same data set, but with the minimum removed. For both plots, the median was 6. Why did the median remain the same when the 1 was removed? And that's because the middle two numbers must have both been 6. So when the 1 was removed, the median stayed the same. And then part B says when 1 is removed from the data set, does the mean remain the same? And you could explain your reasoning differently than me, but no, because the total will decrease by 1, the number that we removed, and the 1 is less than the mean. And then we will divide by 19 instead of 20. And previously we would do the total, add up all the numbers and divide by 20. Now we're removing one number, so we're only dividing by 19. So the mean will increase. So our total is only decreasing by 1, but that number is less than the mean. So when we divide by 19, the number is going to go up, or the mean is going to go up. Number 9, in places where there are crickets, the outdoor temperature can be predicted by the rate at which the crickets chirp. One equation that models the relationship between chirps and outdoor temperatures is this one, where C is the number of chirps per minute and F is the temperature in degrees Fahrenheit. So suppose we had 110 chirps are heard per minute. According to this model, what would be the temperature? So we would just plug 110 in for C. And so when we do that, 110 divided by 4, or 1/4 of 110, gives us 27.5. And then we add 40 to this. And so then our outdoor temperature is going to be 67.5 degrees. For part B, it says if it is 75 degrees outside, how many chirps can we expect to hear? So now they're giving us the temperature, which is F, equals 1/4 times the chirps plus 40. So we can subtract 40 from both sides. And we end up with 35 equals 1/4 of the chirps. So then you can either divide by 1/4 or multiply by 4 is the same thing. So 4 times 35 gives us 140 equals the number of chirps. Part C tells us that this equation is only a good model if the relationship when the outdoor temperature is at least 55 degrees. Below that temperature, the crickets aren't really around and they're not inclined to chirp. So how many chirps can we expect to hear a minute at that temperature? So then again, we're doing 55 equals 1/4 of C plus 40. So we'll subtract 40 from both sides, which gives us 15 equals 1/4 of C. So to get rid of the 1/4, you can just multiply by 4. So then we get 60 is equal to C. So that means that there's going to be 60 chirps at 55 degrees. Part D wants us to actually plot this situation, so graph this situation. Now, we did just do 3 different solutions, so if we write these as ordered pairs, we'll be able to plot them. So remember, we want the chirps and the degree, right? So the chirps is our horizontal axis, the degrees or the Fahrenheit is our vertical axis. So from part A, our chirps were 110. So we had the point 110, which gave us back 67.5. So there's an ordered pair for our graph. Part C gave us 60 chirps for 55 degrees. And then part B, which I missed here, gave us 140 chirps for 75 degrees. So we could plot those points here. And let me just bring those down so that we can see them with our graph. Whoops. Okay, so we can go to 110. So this is 80 and this is 120. So halfway between that is 100. So 110 is going to be halfway between here and then at 67.5. So this is 60, this is 70, and then 80. So it's close to 70. Then at 60, we're at 55. And at 140, we end up at 75. Now you could plot some other ones too, right? So you're doing 1/4 of the chirps plus 40. So we could do 1/4 of 80, which really is 80 divided by 4, is 20, plus 40 is 60, so that's going to be a point. 160 divided by 4 is 40, plus 40 is 80, so you can get some of these other points if you want to, and then you could plot your line. Now, I'm going to start it here and just keep going because it said it doesn't model the situation well less than 55. So I'm not going to plot below the 50 or below this number. Okay, because it said it wasn't good below 55 degrees. So I'm just going to start there. You could extend it because this graph does extend this way. So this is also part of the graph. It just said it wasn't really a very good model there. So explain what the coefficient 1/4 means in this situation. So remember, 1/4 is the slope, okay? And our vertical amount, which is the top, is our Fahrenheit or our degrees. And then the bottom is the chirp. So that means for every 1 degree increase in temperature, the crickets chirp 4 more times. And it's 4 more times per minute, right? So for every increase in 1 degree Fahrenheit, they chirp 4 more times. And then explain what the 40 means. So remember, it was 1/4 C plus 40. So technically what that means is that when there's 0 chirps, we can expect a temperature of 40 degrees. Now, they told us that the model doesn't model that well, but that's what the equation means, is that at 0 chirps, it would be 40 degrees.